Diagram shows a wooden structure in the form of a cone mounted on a hemispherical base. The vertical height of the cone is 48 meters and the base radius is 14 meters. Calculate correct to 3 significant figures the surface area of the structure. Take pi to be 22/7. So this is our structure, a cone on a hemispherical base. So this base is a hemisphere. Know what a hemisphere is? Half of a sphere. So we are asked to find the total surface area. The total surface area of this structure will be the curved surface area of this cone added to the area of the hemisphere. That's this part here. This part here. Is that okay? So the total surface area will be equals to curved surface area of cone plus surface area of the hemisphere. So what's the formula for the curved surface area of a cone? That is pi r L. You know that, right? What's the surface area of a hemisphere? Is 2 pi r squared. A sphere would have been 4. Half of 4 is 2 because a hemisphere is half of a sphere. So all we need to do is substitute all the values into this formula. You can either solve this separately and then add your final answer, but I prefer to work like this. So I'm going to substitute everything here. So pi is 22/7. My radius is 14. My L is, I'm not given L. See L here. L is the slant height in this formula, not the real height. The real height is H. So we have L that is not given. So we write down L. 2 times 22/7 times radius again is 14 squared. Now we are stuck. We can't move further because we don't have this L to continue. So all we have to do is to make sure that we find this L. Is there a way we can find this L given that we know our radius and our height? Now let's look at this. Is there a relationship between the hypotenuse, which is the longest side of a right angle triangle? Look at this. This is a right angle triangle. Right angle triangle is formed from this because this is height, and height is always vertical, and this is a radius. Look at this. So this is horizontal. So this is a right angle triangle. Is there a relationship? Yes, there is a relationship from Pythagoras' rule that says that the square of the hypotenuse equals to the sum of squares of the other two sides. So we're going to have L square being equals to 48 square plus 14 square. Okay, so let's solve this now. This is L square is equals to what's 48 square? Punch your calculator. That's 2304 plus 14 square is 196. Adding that together we have 2500. Now let's take square root of both sides. So that gives us, okay, square root always cancels square. What's the square root of 2500? That is 50. So L is equals to 50 meters. So we have our L to be 50 meters. We can now go ahead and put it here. Okay, and then get our total surface area. So let's go ahead and do that. So that becomes 22/7 times 14 times, this is now 50, plus we add this is 2 times 22/7 times 14 squared. Let's multiply the numerator here together and divide by 7. So everything multiplied is equals to 15400 divided by 7. That will be 2 times 22/7 times 196. So we have our work out here. So let me just copy this out. Plus, let's just 2 times 22 times 196. That is 8624/7. Notice the denominators are the same, so we can simply pick one and add the numerators. So adding that, we have 24,024. Dividing that gives us 3,432 meters and a square, since it is area. But don't forget that we were told to correct it to 3 significant figures, so we are going to do that. This is the first, second, and then the third significant figure. That means this has to turn to 0. Okay, in writing numbers in significant figures, after counting, the next digit goes to 0. But before that digit goes to 0, check, is it up to 5? 5 is halfway in our countings from 0 to 10. Is it up to 5? It is up to 5, then it can't just go to 0 without dropping a 1 to the preceding number. That's just a short form for it. Okay, but I know you guys at this level already know what significant figures is. So let's do this. This first, second, third, this has to go to 0. Is it up to 5? No, it is not up to 5, so it will turn to 0, and that will be 3,430. It becomes 0. Okay, if we were up to 5, we would have dropped 1 here, and this number would have been 4. So we have our meters square. So that is our final answer.